Yes, students, in this video we are going to discuss the nature of oxides of transition metals. You know what are transition metals? The metals, the metals which are intermediate between alkali metals and non-metals. They have ability to give more than one oxidation state. They have ability to give more than one oxidation state. Ability to give variable oxidation states. Variable oxidation state means more than one oxidation state. More than one oxidation state. Thus they form many compounds. Let us take vanadium. Vanadium forms VO, V2O3, V2O5, V2O5. In this one vanadium oxidation state on the calculation we get +2. In this one vanadium oxidation state is +3. In this one vanadium oxidation state is +5. +5. Now here lower oxidation state. Lower oxidation state. So relatively small, relatively big size. Relatively big size. You know, big size atom has more metallic nature. More metallic nature. More metallic nature. So more metallic nature. Therefore its oxide is, this oxide is basic. Oxide is basic in nature. This is basic in nature. This is basic in nature. Okay. When I take the compound with higher oxidation state, higher oxidation state. If oxidation state is higher, that is ionic radii, ionic radius is low. Ionic radius is low. Low ionic radius represents least metallic nature. Least metallic or more non-metallic nature. Non-metallic nature. More non-metallic nature. More non-metallic nature. You know, non-metal oxides are non-metal oxides are non-metal oxides are acidic. That's why this oxide is acidic. Acidic oxide. For what reason? Relatively small size. Because of, due to relatively small size. Relatively small size. Relatively small size. Okay. Now what about the compound with intermediate oxidation state? Whenever compound is having intermediate oxidation state, this is in between metallic and non-metallic or basic and acidic character. So this is amphoteric oxide. Amphoteric oxide. This is amphoteric oxide. In the similar manner, we will explain the nature of chromium oxide, chromium trioxide, chromium trioxide, chromium chromium Cr2O3 and CrO3. Cr2O3 and CrO3. Now in this one chromium is +2, here chromium is +3, here chromium is +6. This is the lowest oxidation state, whereas this is the highest oxidation state, whereas this is intermediate oxidation state. Intermediate oxidation state. So the oxide with the lowest oxidation state is basic in nature. This is basic oxide, whereas the oxide with highest oxidation state is acidic in nature. Acidic nature. Acidic in nature, whereas the oxide with intermediate oxidation state is amphoteric. This is amphoteric oxide. Amphoteric oxide. In the similar manner, oxides of manganese are discussed. Oxides of manganese are explained. Okay. Now for this one, this is lowest oxidation state. This is the intermediate oxidation state, whereas this is highest oxidation state. I told you lower oxidation state. Oxide with the lowest oxidation state. This is basic in nature. It is basic oxide, whereas with highest one is acidic oxide, whereas intermediate one is amphoteric oxide. amphoteric oxide. Thus we explain the nature of transition metals. Okay. Here what are transition metals? These metals are able to give more than one oxidation state. That's why they form more than one oxide. Whenever a compound is forming more than one oxide, the oxide with lower oxidation state is acidic oxide, whereas the oxide with highest oxidation state is oxide with lowest oxidation state is basic, oxide with highest oxidation state is acidic, whereas intermediate one is the amphoteric one. So lower oxidation states represents the basic nature, oxides with a higher oxidation state represents the acidic character, whereas intermediate oxidation states explains the amphoteric nature. Thank you.